Hi, this is a video on the homework project that you're going to do for Chapter 11, Inheritance, and it deals with creating a triangle. And I provide you with a link, and that link contains all these files that you see here. Test shapes, shape, circle, and rectangle. And so I want to go over the source code for this project. It's basically a starter code for you to go ahead and create your triangle class. And so here's the deal. I took my template, and of course you're going to put your name and fill in all this information here in the global comment. And I have a package called shapes, so all of my files are in the shapes class, because anything in this shapes package, because anything that has to do with shapes should be in that, in its own package. And so I changed the template to say test shapes, etc. And so my process is where I actually start dealing with the code. And print, okay, enter shape, C or R for circle or rectangle. Now this code over here, I want you to convince yourself, basically grabs the first character that the guy types in. If the guy types in a complete circle word, it'll grab the C and capitalize it and return that string. I want you to take a look at that code for yourself. So what I'm going to do in line 33 is create a generic shape, and based on that shape that I just typed in, if I typed in C, then obviously I have a circle that requires a radius, and I could go ahead and specify the color, whether it's filled. And when you run this, you have to type. You can type in black. You can type in true or false. When you do a boolean, you have to type in the full word true or false. Clear your keyboard, and now new circle is passed all those parameters I've typed in, and that should return. And that's compatible with a generic shape that we have here. And so do the same thing basically for rectangle. Instead of radius, you have length and width, and you can convince yourself that that's basically the same thing as what we have here. But in line 55, we're creating a whole new rectangle that has a shape. And if I typed in anything else that doesn't begin with a C or an R, it's a bad shape. So line 62 to 66, if shape wasn't assigned anything, then shape would be null because it starts off with null. But if it's not null, I must have typed in an R or a C, so therefore I can go ahead and print out what kind of shape I have here, because implicitly that print line is going to call the toString of the shape. Now remember, by polymorphism, what will happen is you're going to have a shape that has either a circle or a rectangle or a triangle, because you're going to have to change this code. You're going to have to change this code to accommodate triangles, so it shouldn't be a big deal. And it'll print out what the type of shape you have. With the perimeter goes to the class that has that perimeter defined, and area, get the area. So basically these three lines right here, 63, 64, 65, will print out different things depending upon what's actually stored in a shape. And there's no if statement required here. It's just going to output different things. So basically, you're going to have to, embellish this by maybe, adding another triangle prompt here, and case T, and then do the rest there. Now let's take a look. Let's pretend we had a circle. That's all we really need to talk about, a circle. Or the same thing applies to rectangles, but circle. We'll talk about circle. You'll notice that a circle extends shape, so a circle is a shape, which is the reason why you can assign circles to shapes. Okay, now these are three constructors I have here. If I don't give it any parameters, then of course what I'm going to do is call another constructor. This is this as a function call, a method call. This pass it. If you don't pass it anything, then by default you have a white circle, radius 1, and it's not filled in. This calls another constructor down here, and we'll talk about that later. Now, if you only pass it a number, then what you're going to do is you're going to pass that number, white and false, to this constructor here. And this constructor is your workhorse, because if you provided all three parameters, then all those parameters get used to fill in the fields of the circle. Now, this is important to understand. the first thing that gets called when you create a circle, you need to establish the shape. The shape has to be initialized. You call super. Super has to be the first line in your constructor, so that this super calls the shapes constructor here. We'll talk about that now a little bit later. Line 26, if you get to line 26, then it's assumed that the shape has been initialized, its color and whether it's filled or not is initialized. Then you can go ahead and set the radius for this circle to be whatever you specified, radius. Now, let's see. Well, I guess we'll talk about rectangles as well. Rectangles pretty much are the same thing. Okay, I have constructors, and if you take a look at this constructor, this rectangle constructor, with no parameters, what you're basically doing is, I don't see a super there, but if you don't put the word super, the compiler will automatically insert the super call to the default constructor of the shape. You have to go ahead and initialize the foundation of the class, which is shape, before you can create a rectangle. Now, rectangle here, with only two parameters, length and width, okay, this calls this. There's no super here, because this, you're delegating the execution of this method to another constructor, and that other constructor is going to call the superclass's constructor in line 26. And after the superclass is done, you're going to go ahead and initialize the length and width with those values. Now, super gets called, yes, okay, sure. In this constructor, super gets called with no parameters, so that the default constructor gets called. But that's all right, because by default, length and width are considered zero, have values of zero for their parameter, for their values. So that's why by default, this is basically what happens. These are zero. You don't need to go ahead and do this. It's not wrong, but you're doing something that the computer would do anyway. So let's get rid of that assignment and get rid of this. And in fact, if super gets called automatically, you can just go ahead and get rid of that as well. So that's the constructors. That's how the thing gets initialized. Let's take a look at shape. Now, you're going to see a word called abstract, and abstract basically means you cannot create an instance of shape. And that makes sense because you don't know what a shape is. Is a shape a rectangle, a triangle? Is it some generic, glob? We don't know what that shape is, so we shouldn't be allowed to create a new shape. But that doesn't mean that this doesn't perform an important task. This establishes what circle is a shape, a rectangle is a shape, a triangle is a shape. You can go on and on with this. The shape establishes the base behaviors of all shapes, of all the subclasses that inherit from it. Now let's go through here. Here's your private fields that we have. If they're private, you pretty much need to define getters and setters in order for you to access these fields here. But that's all right. Here's our default constructor. White. There's no dimensions to this, so all you can do is set whether it's what the color of this generic shape is. Here's the constructor with two parameters, and you use those parameters to go ahead and fill in the color of the field. We got our getters, we got our setters. We have a toString, and then we've got a couple of other parameters here, with actually methods, getArea and getPerimeter. They're public, but they're abstract. You'll notice there's no body here, and that means that in order for you to go ahead and create an instance of a subclass, you have to define getArea. What does it mean when you have getArea with no parameters? What should it return? Well, it should return a double, but it should represent, if getArea is a circle, it should represent the pi r squared. Same thing with the perimeter. Okay? Now, let's go back to these other classes. Let's go back to rectangle. And rectangle, this goes ahead and defines. Okay, this actually defines get area for you. In fact, if you were to do this correctly, by default, the computers actually Eclipse will actually put this statement in there, override. Okay, if you were to do this correctly, there's a specification that only the compiler will see, and that says that the next method is going to override what the parent has provided. Well, the parent provided an abstract get area, and so you need to go ahead and say get area, no parameters, return double. Well, there it is, with length times width. It prevents you from doing something like this, integer x. Okay, look at what I just did there. You told me that the compiler was told that get area with one integer parameter is being overridden. Well, the parent didn't have a get area that takes one integer. So, you know, what are you doing to me? You could go ahead and say, well, get rid of that. In this case, there's no error, but the compiler is going to say, well, I'm going to create another method called get area that takes an integer parameter. But I think it's a good idea to put this at override to indicate it's good documentation. If you didn't have the source code for shape in front of you, then that override pretty much tells me, hey, I guess I'm overriding that method. Same thing here with the parameter. Copy this. I'll put that over here, and let's do a source format. Let's clean this up a little bit. Okay, and I guess we can also put an override on the toString as well. Source format that, because you are overriding what the shapes toString is all about, and I guess that's good there. And then how about the circle? Circle is pretty much the same thing. Get radius. I threw in a little some code in the system here to introduce you to exceptions, and you know, it's not hard to understand. You're not responsible for it, but in Chapter 12 we're going to do exceptions. Here I created my own little exception called invalid radius exception. Well, if the radius is negative, you can't have that's not a valid circle. So return something that's invalid radius exception. The name of the class itself sort of describes what it does. Pass it the bad radius so that you can report on it. But if execution goes to line 38, I guess everything's cool. So when you throw an exception, all the code in that method gets just doesn't execute. You're done with that method. Someone's got to have to catch that that exception. I'm not catching it here, so I must be catching it to whoever. There must be some code that catches that exception in the method that called setRadius. And if that code didn't have any way to catch it, then the JDK itself is going to accept that error. And you see that a lot in your development when you see that big long list of method calls in red. That scares you when you create your programs. But this is not the code that we need to concentrate on right now. Chapter 12 we'll talk about radius. Same thing. Get diameter, get area should probably be overridden. Sure, let's put an override directive there. Let's put an override directive there. Should I put an override directive on get the diameter? Let's see. No, of course not. You put an override directive if you're trying to override a method that the parent has tried to give you. The override was abstract, but the parent says it's okay. If you're going to override me, you better create a method called get area that takes no parameters. There is no method get diameter. Okay, so this is something that is really just necessary for circles. So that makes no sense. Take that out. Get perimeter. There's your toString there, and here's the definition of the invalid radius exception, which in turn extends runtime exception. And I'll let you play with this. It's not intense code, but we're going to get to it in big time in chapter 12. So I guess that's it. Okay, I guess we can run it and show you what this is. Let me go ahead and run this code here. Test shapes. Run it. Okay. C. See, it's a radius. I'm going to put a radius of 2. Color black. Is it filled in? False. And this is the 2 string. Okay, right here is the 2 string that gets printed out. The perimeter is 2 pi r. That makes sense. Area 12.5. Okay, I guess pi r squared works for that. Do I want to do this? Yes, I want to do it again. And this time I'm going to type in rectangle. Length and width 8 and 4. Color blue. Filled in true. And you can see that that's what comes out there for the execution. So you're just going to take this code and add triangle support for it. Okay. Let's see. I'm bored with this. I don't want to do this anymore. So for triangle support, what you're going to need to do is understand you're going to enter 3 numbers because you have 3 sides to a triangle. They're not just right triangles. They could be triangles that are of any sides. That they have the 3 sides that you enter have to be legal. Okay, you can't enter 100, one side 100, and the other sides are 1s because the 1s doesn't form a triangle. Okay, so the idea is the sum of 2 sides, any 2 sides, the sum of any 2 sides has to be greater than the other side. Okay, let me say that again. In order for that to be a valid triangle, the sum of any 2 sides has to be greater than the 3rd side. That's what makes a legal triangle. You have to add the logic for that. It's a little more complicated than circles and rectangles, but that's okay. This is a project. You need to develop this code. And then there's something called, if it's a legal triangle, there's something called Heron's formula. It's in the textbook. You can look it up. You can Google Heron's formula, and that's just given 3 sides of a legal triangle. That formula will get its area. It's not a squared plus b squared plus c equals c squared. That's a right triangle. This is a generic triangle. Heron's formula will let you do that. And that's it. That's it. So, okay. Happy coding. Get this program done. Take care.